All right. So let's talk about the other big topic for the next couple of weeks: web services. Right. Um, so in the at the so at the turn of the century, there was a there was a there was a lot of use of the web as a tool that could solve everything. Right. It was growing exponentially. People had access to information that they never had access before. Folks were being able to collaborate where they couldn't earlier. Barriers were being torn down, so a lot of people saw a lot of potential of what the web could give us, and we still didn't know where we were going. We were still inventing as we went. But I guess a lot of investors saw a lot of big potentials down the line, and I guess we weren't mature enough to know really what we could build, and I guess we overpromised what we could deliver, so I guess bitter reality set in a little later, and a lot of those dreams were dashed. But anyway, in that tumultuous time. One of the big problems that we were trying to solve was that typically when organizations grow organically, it's very common that folks will use all sorts of disparate stacks and technologies, and that are usually very very hard for them to collaborate. Right? Imagine. Being a car company, and as you grow, you buy a small car company, and maybe you're Hertz, and you buy Avis, and you buy Alamo, and you buy and you just that's one way of growing. And as you, or even in the financial sector, right? Bank of America purchasing all these other institutions, and each one of those institutions probably had its own databases, its own services. Some folks were using one language versus another language. The communication protocols were different. The data schemas were completely different. So it was very hard for some folks in some part of the organization to talk to some other part of the organization. You had the data here, but it was isolated. I can't get at it. It's there, but I can't join it with this other data to make any use of it. Or I have all this data, but it's just not valuable to me. I just can't access it. It's not easily accessed. So this was a huge, well, still is. It's a huge problem, and folks were looking of ways to get over that big problem. So folks were selling us the idea that these new things called cell phones and mobiles, we'll be able to identify that is your anniversary. And it'll detect that you forgot that tomorrow's your anniversary, and don't worry, I made reservations for you at this restaurant. I already ordered flowers, and I booked a flight to whatever. I guess maybe Google will be able to do this pretty soon. So anyway, this was what was being sold to us. That a lot of things that were going to be automated. And things would be able to talk to each other seamlessly, right? Knowing that you were going to miss a flight or something, it would identify that I'll reschedule you, and it talks to the hotel, it talks to the car company, it talks to the airline, and they can all talk to one another, right? And could share data amongst themselves and resolve this issue, right? And a lot of effort went into solving this, right? We failed miserably. It was much harder than we possibly thought. But the idea was good. It says you have all these disparate systems. They're all using all sorts of different stacks, different technologies. How about if you leave it? It says, well, what do I do? Does everybody go Java? Does everybody go C#? Does everybody go? How do I standardize this? How do I make this standard? So the idea was, well, what if we somehow create an abstraction around each one of these, right? And create endpoints that are now abstracts what's inside, right? This abstracts what's inside, and then we can have a connection between these two such that is compatible between the two, right? If your orders here you have for you an order, one of the fields is customer and one of the fields here maybe it's client, but they have the same meaning, right? These endpoints would resolve that inconsistency, right? That there would be a transformation where you transform the data model from this system into an equivalent data model in the other system, and the translation would be automatic, right? And we could all agree that the transfer protocol is going to be some agreed upon format. At that time, the format that was most popular was XML. Right? So if we can all agree on XML, and if we can all agree that the transfer is just going to be over HTTP, over the port 80, nobody really cares about port 80. There's no security measures, right? Everybody thinks it's just ASCII code, just going back and forth. You don't even have to ask your admin to open up a port, right? It's just already open. Nobody really cares about HTTP, and you build all your infrastructure around this idea, right, of these abstraction layers that abstract what's inside. If we can all agree on that, we'll solve all this integration problem. Okay, this turned out to be much harder. And, you have schemas here that are very some schemas are very normalized. Some other schemas are denormalized. Some folks, some of these data over here needs to be calculated on the fly. And some of this data is actually stored. Some of these are long-running joins that take forever to do, very slow, whereas this is very fast. So it became very hard, especially if you start considering that some of these might have to run on a transaction, right? Where I need to wait until this commits. I need to wait for this to say yes. I need to wait for this to say yes for the whole thing to say yes, right? And some of them take milliseconds, whereas other ones take hours. Some of them take days. I need to wait for a permit that comes from the government and that might take a whole week, right? Before I can make a decision whether a long-running transaction is successful or not, right? So this was much harder than we could ever expect. But nevertheless, the technology survived, right? The ideas of exposing data types, data models, right? And over HTTP, over an agreed upon format, that still survived, and it's become very ubiquitous today. Right? It's very common that organizations make their data available. Right? They find it as a new way of monetizing their data storage. They've been around in business for years. They have this data sitting there for decades. It's been there. It's typically only being used locally, internally inside of the organization. And now, because of these new technologies, they're finding ways of monetizing data that's been just sitting there, right? That has been valuable internally, but now because they can make it available to other folks, right? That can connect and says, "Ooh, you have information about buyers for the last 30 years." And I can find patterns. I can throw at it at an artificial intelligence and identify all these really cool data mining algorithms. I can extract all sorts of behavior. Give me that. Right? I'll pay for that. I'll pay for that data. I'll just expose it at a data point, and I can access it. I can query. I can retrieve it. So this notion, this idea of exposing data models is the overarching idea of web services, making them available over some agreed upon protocol. So we'll be using web services quite a bit from now on. And now that we've been using web services for a couple of decades, some patterns or some best practices have been identified. Okay. It says, okay, well, yes, you can expose anything at whatever URL endpoint you want. Well, let's agree on some best practices, right? So, for instance, one of the best practices might be that there are some common data models that you find all the time, right? So it might be just a single table, and you want to expose that. Yes. So a common pattern is that you map that data model to an endpoint that might have the name of the entity that you want to access, right? So you want to access A. Okay, well, what is it that you want to do with A? Well, there are typically just 4 operations that you want to do with A. You can retrieve it, you can update it, you can remove it, you can instantiate a brand new one. Those are the only 4 operations that you can do, right? The CRUD operations. Yes. Commonly we will map, since we decided on HTTP, we will map the CRUD operations to common or equivalent HTTP actions such as post, get, put, and delete. Okay, these are the CRUD operations, and these are the HTTP equivalents. All right. Along with the URL that would capture the name of the entity that you're manipulating. In this case, is A. You're exposing A. You want to create a new A? Well, you need to post to A. You want to retrieve an A? Well, then you do a get A. You want to modify a record in A? Then you put to A. You want to remove a record? Then you delete to A. Okay. Now, depending on the operation, you might need to know other things about A. Right. So, for instance, if you are posting to A, well, you need to give me also some data. You need to give me some data information. Right? You need to give me what are the values of A. Yes. If you are retrieving get A, then there's 2 interpretations. If you say get /A, well, the common interpretation is that you since you're not telling, because A might contain several records, right? Hundreds of records. Since you're not specifying any one particular record, the default interpretation is that you must want all the records in A, right? That must be you want the entire list of A's. If instead, perhaps you additionally provide for a particular a unique identifier, then the interpretation is different. You must mean that one particular record whose primary key is 1, 2, 3. Right? That must be the interpretation. Typically put that means that you're modifying, you're updating. It must be that you're updating something that already exists, right? So you must tell me which one of these is the one that exists, right? So let's see. Let's write this again. So for post, typically it's A and then some data. Right? For get, there's 2 versions, right? You have just A, and then these are all. So get all A's, right? Or is A followed by a primary key? So get A with ID equal 1, 2, 3, right? For put, it can only be that you're updating something that already exists, right? So you must be that you also provide the ID, and you also provide the data, the new data, right? The new data, right? So you identify the record that you're updating plus any new data that you want to update that record, that particular record. Right? And finally, the delete is you're removing something that already exists. So it must be that you're deleting, some particular record whose ID is equal to that particular ID that you're providing. Make sense? All right. So there it is. So you have these. I often call them 4 plus 1, because here the reader, the read has really 2 versions. They get all the A's or get a particular version, a particular instance of A. Now this could be a little further, right? This could go a little further. So so get actually has a few more. Which ones could there be? Well, if you notice in SQL, the insert, the update, and the delete, right? Those are fairly common. They other than perhaps providing a where clause, right? They're fairly standard. Whereas a select statement is typically, we spend a lot of time talking about the select statement, right? Because it has groupings. It can have all sorts of very complex. You can have all sorts of complex primitives or predicates, right? Where this is, where the salary is so and so, the date of birth is whatever, how long has been enrolled, how many seats are available. So you can have a very, very complex predicate. So this query of A, right? This could have additional predicates. So if you have a predicate, meaning that it's something beyond the primary key, right? Maybe you're retrieving somebody by salary or by date range or whatever. If it's a predicate that you're trying to query, then typically it will be added as a query parameter, right? Where you have a query and then you have the field names where A is equal to X, Y, Z, and B is equal to 1, 2, 3, and whatever, etc. Okay, so this might be, I'm looking for an employee whose starting date is equal to this, whose salary is equal to that, and whatnot, right? And you can provide all sorts of query. All those fields are not primary keys, right? Those are just regular fields in there. If it's a primary key, then it would be provided as part of the path, as opposed to part of the query. Make sense? Okay. So all these conventions, all these practices of providing a particular syntax for what these URL patterns are, we usually refer to them as a REST service. Okay. Now it doesn't end here. It goes on beyond considering also any relationships that a particular entity might have with other entities. For instance, consider relationships between A and some other class. Say you have A that has a relationship with B, right? You might have a one-to-many relationship, and maybe a relationship of B with C. Okay, so what this generates is a data map, right? Where that you want to be able to navigate, right? It's a hierarchical data map where the starting point is A, right? So you have A here, and you can have any number of instances of A, and given if you pick any one A, say you pick this one, then typically the B's are going to have references to all those A's. Yes. Right, A's is going to be foreign keys that go back, so this might have to be that here's B, and these are all the B's, of which maybe a subset of those reference back to that particular A. Yes? Right? And from here, if you pick any one B, right, you then, this is all the instances in C. If you pick one particular B, that maps to a subset of C's. Right, so basically, you've created a hierarchy that you want to be able to navigate, right? Starting from picking an A, then moving on to a particular B, and then a particular C. So since this declares a kind of like a hierarchy, right? Well, the URL patterns, right? The URL syntax actually plays nice with that, right? It's also hierarchical, right? The slashes that we typically use also for maybe navigating through a folder structure. Yes, folder structure by nature is hierarchical, right? You have folders, subfolders, and whatnot. Allows you to navigate this data space, right? Where you might provide an A, then you might provide a particular instance of an A. Now you've picked which A do you mean, right? And then you might then navigate to B, and then you might pick out a particular B. Right, and then inside of C, you might pick out a particular C, and so on and so forth, right? So this syntax actually allows you to navigate this data space, right? So web services would make sense that it would use syntax such as this that would allow you to navigate this the entire data space, right? With meanings, with the following meanings. If you say /A, you must mean all the A's. You must mean the entire set of A's, right? But if you pick one, you must mean that particular A, right? And if you go on to B, then you must mean all the B's, right, for that particular A. You must mean this entire set of B's, right? But if you pick one particular one, right, then you must mean that particular B, right? So this is 1, 2, 3. This is 2, 3, 4, right? And if you say C, you must mean all the C's for that particular B, or this subset over here, right? Or if you pick out a particular C, then you must mean this particular C over here. That makes sense, right? So this certainly allows us to navigate, to do a select, right? Do a retrieval, data retrieval of either one particular instance or all those subsets of those instances that are related to parent, where you have a parent-child, parent-child, parent-child relationship, right, moving from left to right. And so certainly this maps nicely, at least with a get, right? If you do a get A, and then you're listing all the A's, or maybe just one A, or maybe all the B's for that particular A, or that particular B that belongs to A, or then all the C's that belong to B that belongs to A, and so on and so forth. Make sense? Right? Now, some of these are somewhat redundant. Right? For instance, here I have B, and I know the idea of B. But this would be identical if I would do this, B, 2, 3, 4. Right? Where I only really need the 2, 3, 4, which uniquely identifies the B. Right? So it would be kind of redundant having to also include the scope, the previous scope above. Right? So oftentimes we take a shortcut and say, well, I only use the hierarchy when I want to specifically identify a subset of B's that belong to a particular context. Yes? But if I know exactly the ID, right, I can skip the line and not include the above context. That makes sense? Yes.
So what you're trying to get at is if you know exactly where to find
a particular record,
B23, then you can just jump right
You can just jump right in there. Right.
However, if you have to search through many data sets in order to find B for this example, you must.
Yes, whenever you need the context, then obviously you need to provide it.
Okay.
Right? When you need to specify a relationship, right? That say, oh, there's a parent-child relationship here, right? And I only want the ones that relate, right, over a particular reference. Yep. Yeah. Oftentimes we'll skip here. Like for instance, if I want all the C's that belong to B, I don't really need to know A, right? So I can just do this, right? Or if I'm selecting a particular C and I know the particular ID for C, I can just go to C directly. Okay. Anyway, either one or the other. When you choose to use the fully qualified coordinate. Right, this gives me like a coordinate. Right, this tells me exactly where I am in my data space. Or that you choose this particular indexing, then use it wisely. All right, so that's for get. For all the other ones, then you have different interpretation. If you do let's look at post. Right, so if you do a post. Well, the interpretation is that I am posting to all the collections. I am adding one more element into the overall collection of A, right? It would make no sense for me to provide an ID here, right? That to post to something that already exists, maybe that makes no sense, right? So typically we will not implement that, right? We'll implement maybe just this one, okay? But if you say this, then that makes sense. I want to add a new B, right, to the A, right, that belongs to A, to this particular A. Meaning in this subset, I want to add another one in this subset. I want to add a whole bunch of them that all belong to the same A. See that? So this one makes sense. Right? I'm adding a new B to A, to this particular A. Yes? But then this might make no sense. Right? That you're adding something that already exists. So typically in a post, the URL always ends with an entity name. Right? It will not end with an ID. Okay? Okay, and in all cases, you are always passing new data to be created, right? And then you satisfy the relationship. Right, so that's post. On the okay, we know get, right? Get, we are either getting the entire collection, we're retrieving a particular instance, okay? And that particular instance, I'm providing the ID. I know exactly the record that I want. It might make no sense to provide a query here, right? It makes no sense to query because the query, right? I already know exactly the record that you want. It makes no sense to filter what? Right? I already have that one single record. There's only one record who's 1, 2, 3. It makes no sense to query anything here, right? As opposed to providing a query like this. So you have here a query. That makes sense. Right, I'm looking at all the A's, but only the ones that match this predicate. Right, so it's a subset. It might be unique. It might not be unique. So this might come back as an array of things that match that query, or it might come as just one single element, right, that matches that particular query. Yes. Right. So we already looked at the other examples. For put, right? So for put it would be. This might make no sense.